So I'm with you. I'm with you, Kate.
Charging.
Yes. Sorry, YouTube. Friends, check this. Check this. Here's some inferential statistics presented back in 2011. It's a little bit old now, but it's still valid. Still valid. See if you can get in there. See if you can identify the population. See if you can identify the sample. See if you have any concerns with the study as done. It's a Gallup poll. It's a Gallup poll. Get in there, identify your population. Identify the limitations of the study. Did Gallup do a good enough job? What's your take? Do you agree with their conclusions? Who wants to start? Anything you want. Scott, get in there.
The population that they took the random sample of tends to be continental U.S. instead of coastal and Alaskans.
Very nice. Scott has noticed something. The headline, U.S. oil drilling gains favor with Americans. America is 50 states, 2 of which are Alaska and Hawaii. But Scott wisely went to the bottom. And just FYI, when you read Gallup polls, sometimes these things, I showed you a short one today, sometimes these things are 2, 3, 4 pages long. That stuff's at the bottom. The stuff down there, those 2 lines at the bottom. Results are based on telephone interviews conducted with a random sample, at least the word random in there, that's good. Random sample of about 1,000 adults aged 18 plus, so voting age Americans, which is not mentioned in the headline either. Americans is different than 18 plus Americans. Half the population is above 18, and the population is below 18-ish, somewhere, and I think it's probably a little bit skewed. Living in the continental U.S., selected using random digit dial sampling. Okay, I'm down with the random digit sampling. That's cool. That's very, very cool. I'm glad they did that. So I'll give them the random check. I'm a little concerned about the slight misuse of the word American, though, because it's not all Americans. It's contiguous 48 Americans, right? Why was Alaska and Hawaii? Why were they removed? I don't think it was nefarious, honestly. I don't think it was nefarious. I don't think it was a negative thing that they removed them. I think they probably only wanted continental U.S. because of the idea of it being the continental U.S. Well, actually, what's your take? Why do you think they excluded them? Max, go.
Well, I wasn't going to say anything
Poison your
about exclusion.
Yeah.
But, I mean, for the U.S. offshore drilling, like I would give that a check for being okay because you know it's not like you're just offshore drilling outside in like Alaska or Hawaii. It's going on in the Gulf.
True. This was not that long after Deepwater Horizon in the Gulf.
Yeah.
And they asked Louisianans, and they asked Mississippians and Alabamans. If I'm saying that right.
Maybe it's just hard to contact people.
That's one thing. That's why I say it's not nefarious. It might be a demographic issue. It could also be a statistic issue. Alaskans get paychecks from petroleum companies. Anyone from Alaska here? But they do. They get paid by the petroleum companies for the petroleum that is drilled out of Alaskan soil. These numbers might get artificially inflated. Hell yeah, I'm in favor. I get money from it. So that might not be representative of the rest of the United States. Now, there aren't that many Alaskans, so throwing them in the random mix I don't think is a bad idea, but maybe it's, as Max said, maybe it's a problem that way. Cool so far? What else? What else you got looking at this? Please, Andrew.
So, tell me about the 95%.
Oh, brother, I'd love to. Let's talk about it.
Plus or 4%. Yeah.
Andrew, thank you for the segue, brother. That was perfect. Here's the problem I have with this headline. I agree with one of the 2 statements that's made. Let's come to peace with the Americans bit. Let's just say the 48's enough, of the states is enough. Let's make peace with that slight glitch. Let's talk about these 2 statements. U.S. oil drilling gains favor with Americans. Support for offshore drilling and oil exploration in Alaska reached new highs. Okay, let's take the first one. U.S. oil drilling gains favor with Americans. Here is the poll that deals with that question. 60% favor, 37% opposed. I oppose this statement, though. 6 in 10 Americans favor increasing offshore drilling. No. 6 in 10 of who said, yes, we favor? Who did they ask? Who in particular? And who of them in particular? see what I'm getting at here? They asked that many 18-plus-year-old voting age Americans. So 60% of those 1,020 said, yes, we favor offshore drilling, or whatever it's, yeah, we support increased offshore drilling. The problem I have is, they took that 6 in 10, that 60%, and said all Americans favor it. No. 60% of your sample said, not 60% of your population, 60% of your sample. So Andrew, what we have to do is we have to apply what's called a margin of error to that 60% and admit the fact that we didn't ask everybody. So we have to put a plus or minus on our number and say, you know what, 60% of our sample's in the middle of that, but it might be as low as 56% or as high as 64%. That's what the margin of error is. It's the admission, and this is not like a bad thing. It's the admission and the realization of our sample isn't perfect. It's got error in it, and it has to have error because we couldn't ask everybody. So you put the error estimate on there. 244, we explained how to actually calculate that bad boy. We'll get to it. Please, Kate.
As far as the second poll goes, the margin of error makes a huge difference in your outcome.
Give me 3.5 minutes.
Okay.
Kate, if you don't mind. Because I want to stick with the first one just for a moment. So, assuming we rephrase this statement, not 6 in 10 Americans favor increasing, but between 56 and 64% of Americans favor increasing. Do we agree that more favor than oppose? Absolutely. Because even if we apply the 4% to the 37, what's the highest it can possibly get? 41, which is still lower than the 56, which is the lowest of the high. So I agree, yes, even with the margin of error, more support than opposed. Yes, I agree with this statement with a slight change in language from 6 and 10 to 46 to whatever it was, 56 to 64. Is that okay? Kate nailed the problem with the second statement, though. Support for offshore drilling and oil exploration in Alaska reached new highs. Her eyes went right down to this poll here. Do you support ANWR drilling, which is offshore up in Alaska? Yes, they should, 49%. No, you should not, 45. Clearly, 49 is higher than 45. Right. 49 is higher than 45. So in your sample, you could say, in our sample of 1,021 adults, more said yes than no. But you cannot say American support. The American support has to be adjusted with that margin of error. So the best you could say is at least 45% up to as many as 53% say support, as at least 41% up to 49%. What's the problem with those numbers? They overlap each other now. They could be equal. Not only could they be equal, they could actually imply the opposite of what they're claiming. Remember how we said this could be at least 41 up to 49? And this one could be at least 45. What if that's 45 and that's 49? Then it's the opposite of what they're saying. That's called a statistical dead heat. And that's when you put your hands up and you go, we can't say anything about this. They're too close to call. Approval ratings happen all the time. Obama dropped again. He was at 48, now he's at 47. No, he's not. It's a plus or minus 3% margin of error. He might actually be higher this week than last week. And why are you checking every week anyway? You know how fickle Americans are. Good Lord. So, when you see huge gaps like this, you go, okay, as long as the data is good, that's telling us something. When they're that close, it's hands up in the air, it's hands up, we can't tell. That's why margins of error are so important. That's why they're so important. Now, if the margin of error was 1 percentage point, would you agree with this? That this is higher than this? Hell yeah! Because 49 goes as low as 48, 45 goes as high as 46, and 48 and 46 are definitely different from each other. But they're often never anywhere near 1%, because you have to poll like 5,000, 6,000 people to get that kind of a margin of error. There's a direct correlation between sample size and margin of error size. We'll get to that in 244, I promise. For right now, just know how to apply that margin of error. Sounds like you guys do. Good stuff so far? Yeah. All right. Now that we understand the implications of data that we've got coming at us, I want to talk about how you should actually put it out there in the world a little bit. That's what I'm going to spend the rest of the time doing. How do we put this data out in the world? So here's a bunch of numbers that a statistician collected for a small little company. How should that statistician give these numbers to that company manager? Like this? This is how many products an employee makes of the 20 employees at the company, how many they make. This is one way to give it to them. Here's a bunch of numbers. Here's my paycheck.
It's not meaningful.
Why is it not meaningful, Robert? Please.
I don't understand what the hell you're trying to tell me.
Good. All right, what are you trying? Are we trying to look at what the average products made are? Are we looking for trends of products made? I love it, man. I love it. Yeah, this is too much of a jumble. What's the most products made by an employee?
39.
Good, you found it. 39. Good. What's the least number of products made by an employee? Now imagine there were 1,000 employees. Could you find the min and the max? Oh, well, you could. It would be annoying, wouldn't it? You could scroll through. Oh, there it is. Right? Yeah, this take a while. Or use Excel. Min, max, right? But it's annoying, right, Nat? Yes. Much better way. Now, there is an advantage to raw data, and that's that you actually have all of it. Here's another way of presenting the same data, which is called a frequency distribution. Take a look at that and see if you can see how this is another way of looking at this. See if you can see how they're related. This is numbers of products, all 20 of them. This is another way of viewing. Why, for example, is there a 2 in the frequency column, 13 to 15?
Because two of those people that they have there,
Candida, correct?
Yes.
Yes.
Two of those people are the ones that are doing that.
Yes! If you count up the 13s, 14s, and 15s that you see in this, there are 2 of them. There's a 15 and a 14. Thank you, Natalie, right there. There's 14 to 15. There's 2. There are 5 19 to 21s, because if I go through 1, 2, 3,
Bottom right.
4, 5. Thank you. Look it out for me there. Appreciate it. Now, why is this a little better than this? It's organized, Andrew Jensen. Thank you very much. Robert, does this make you a little bit happier as far as what you're looking at?
Sure, as long as I know what the terms are.
Good! It's all about the definitions, man. It is all about the definitions. As long as we know number of products. One thing, one of my classes picked up, and I was taking this for granted. What if the person that's making 39 products is making something easier than the person making 10? What if the thing that they're making is 4 times easier to make? Well, then they should make 4 times as many of them, logically, right? So I told them, wipe that from your mind. They're all making the same product. And we're just measuring the variance in that. It's good. But as long as you know what you're talking about, Robert, that is key. And that overrides everything in this class, really. Everything we're talking about is once we get the good data collected, we can analyze it and present it. But your point is super valid, super valid. Keep thinking that way. Good. What's the disadvantage to this frequency distribution?
General,
Say that again.
general, sort of general.
In what way? Go with that.
Well, you mentioned that before, you know, like you don't know what kind of products, but you'd have to put that up there, like all the same products.
Let's assume we have. I'm stripping it down to just the actual presentation. Let's assume all the products are the same. But there is a generality that we have lost. We've lost specificity from here to here. How have we lost specificity? Because remember, you don't get this and that. You get one or the other. Kate, go.
Instead of seeing the individual numbers, you're seeing the group 10
Yes.
to 12 or 28 to 30.
4 people from 28 to 30.
Yeah.
How many of each? You lose that, don't you?
Yeah.
We have a fix for it, but right now we lost that. But don't worry, there is a fix, and I promise you, we'll get to it on Tuesday. We'll deal with it, and we can talk about our keys. Please, Max.
Well, why wouldn't someone just put all the numbers that the 20 employees, just like both of the...
Oh!
right next to-
Like, in other words, have two instead of 10 classes?
Well, what I'm saying is, like, you can have your frequency distribution.
Oh, I see what you're saying.
To
That's a good question. There is a type of graph called a stem and leaf. We'll get to that in about 10 minutes that actually does that.
Okay.
And that deals with, but you're saying actually instead of putting 5, put the actual numbers in there. That creates almost more work than having them listed out raw. You can put them in order. That's one way to do it too. List them in order instead of out of order.
Or just have all the specific numbers.
Like all the 10s, all the 11s, all the 12s.
No. Have that grouping.
Yes.
And then also have.
Oh, because you want to be as concise as possible.
Yeah.
You want conciseness. And here's another way of doing it. Tell me what you think about this. This is called a histogram. Do you see how this and this are showing you the same thing? Do you like one of them better than the other? Which one do you like better? Max likes the histogram, Jay likes histogram, I like the histogram, Katie says yes, histogram, we're in favor of the histogram. It's showing you the same data, isn't it? Why do you like the histogram better? Because as humans, we like that second dimension. There's no second dimension in the distribution. It is, isn't it? Because 5 and 0 take up the same amount of space in the distribution, but 5 down here, you can see is that much bigger than this 0 or this 1 or this 4. You actually get a sense of scale, not just a quantitative 5 versus 2 or 5 versus 0, but a scalar, a second dimension. Please, Robert.
Would it be easier to distort that data using a histogram?
Tell me how.
I mean, just by making them a lot larger?
Mm-hmm.
You know.
We saw that in that broadside article, didn't we?
Yeah.
Right?
That's
You
the
have-
problem with that, right?
You couldn't do with this one, unfortunately. Well, not actually, fortunately. This already starts at 0,
Yeah.
nothing to trim.
This one would be hard to.
It would be hard. Now, you could though, by simply saying, okay, you know how it goes to 6? Let's make it go to 5. That'll actually pull the 5s higher. You could selectively group. I chose to make 10 classes, 10 through 12, 13 through 15, 16 through 18. You could go 10 to 11, 12 to 13. Maybe that makes spikes in different places. I mean, there's all kinds of ways, and it's an art form almost, making these things, and you'll take entire classes based on that too, maybe eventually at some point. So honestly, Robert, yeah, there probably are ways of misconstruing it, but what I tend to do with histograms is if I can do 10 classes, I'll do 10 classes. And whatever it falls, it falls. We'll learn in this class how to mess with our TIs and how to change those classes very, very quickly, so get multiple views of data and see if there's any kind of consistencies. But yeah, you're right. You're right. Absolutely. We'll deal with that as we go through this class too. It's easy to mess with data. It's easy to make data look 2 different ways. We try not to do that, or we try to look at it 2 different ways, but not pick one over the other. Look at it all with the same set of lenses. Good. Any other questions or concerns or comments? So we had raw data back here. Raw data is great because you get all the raw data. As soon as you start summarizing like this, you lose that exactness, but we do have a fix for that, and I promise you we'll deal with that fix on Tuesday, starting Tuesday. I did want to pick up a few other, I don't want to do any other kinds of displays today except for the histogrammy types. And the reason I want to do a few more is we haven't talked, for example, how to deal with qualitative data. Everything's been quantitative, number of products, right? Gallup poll, presidential approval rate. Everything's been qualitative, or quantitative. I want to deal with a qualitative data set right now and show you one way of dealing with that, with something called a Pareto diagram. But in order to do this, can we throw the lights on real quick back there if you guys don't mind just reaching behind you? Thank you. I want to make what's called a Pareto diagram to show you how, swing this over this way.